Hello and welcome to Algebra 2 Lesson 26. In this video, we're going to learn about solving systems of linear equations by substitution. So in our last lesson, we reviewed how to solve a system of linear equations in two variables using the method known as graphing. Now, if you took an Algebra 1 course, that was nothing new for you. And of course, if you took Algebra 1, substitution is not new for you, and it's also not going to be new when we cover elimination as well. But it's important to review these concepts so when we start looking at tougher material, it's fresh in your mind. Now, the one thing I'm going to say about graphing, you might say, well, why don't we just use graphing? We've already learned one method. Why not just use that? Forget about the rest. Graphing is very inefficient. If you can imagine having a piece of paper, a ruler, and a pencil, and trying to find a solution that's, let's say, the ordered pair 200, negative 400. Okay, it's very hard to do that. It's not impossible, but it's very difficult. Or let's say you had 1/2, negative 2/5, something like that. It's very hard to use graphing unless you have a small, clean integer answer. And those were the examples that I gave, and I give them on purpose so that you can just get a conceptual understanding. You don't want something where it's just so tedious you forget about it, I'm not going to do this. So we turn to substitution as an algebraic method. This is something you can use no matter how big or small something is, fractions, decimals, whatever you want, you can use substitution. Now, I am going to say substitution works best when you have a coefficient for one of the variables that's a 1 or a negative 1, okay? Now, with that being said, let's kind of dig into this. So solving linear systems in two variables with substitution. So the first thing that we want to do, we want to solve one of the equations for one of the variables. So it doesn't matter which equation you use, doesn't matter which variable you start out with, okay? It is going to be helpful, as I just mentioned, if you have a variable that has a coefficient that is 1 or negative 1, you want to use that because it's easy to solve for that variable. But otherwise, you can use whatever you want. Now, after you've done that, you want to substitute for that variable in the other equation. Now, once you've finished that step, you're going to notice that that equation you're working with is a linear equation in one variable, something we've been solving forever now. So we want to solve the linear equation in one variable, and then what that is going to do is give us a solution for one of the variables. So once I have that, I plug in for the known variable in either original equation. Doesn't matter which one I use. Then solve for the other unknown, and I've figured out the ordered pair that is a solution for this system. And again, I say ordered pair because usually that's what you're going to get. You know you have special case scenarios where you have no solution and an infinite number of solutions. I'm talking about the case where you have one solution. All right, so the last thing we want to do, and it's very important you do this, check the result. So you want to plug in for x and y in both original equations. All right, so let's take a look at the first example. So we have our linear system here in two variables. So we have x plus y equals 5, and we have negative 2x minus 5y equals negative 10. So I would pick one of the equations and solve it for one of the variables. Now, if I look at this first equation, and I'm going to label this as equation 1, so I can refer to it. I'm going to label this as equation 2, so I can refer to it. If I look at equation 1, I notice that the coefficient for x and the coefficient for y is a 1. So it would make it pretty easy to solve for either one. So let's go ahead and just solve it for y. So if I have x plus y equals 5, and I solve that for y, we've been doing this for a while now, I just subtract x away from each side of the equation. And so this would become y is equal to, I'd have negative x plus 5. Now, I want you to think for a second what the equals sign means. Equals is saying is the same as. So y is the same as negative x plus 5. It's like if I have money and I say $1 is the same as 4 quarters. They are the same in value. They don't look the same, but they are the same. If I give a cashier 4 quarters, if I give a cashier a dollar bill, I've presented the same value to the cashier. And so that is $1 either way. Okay, so now that we have solved this guy for y, I am going to plug into the other equation. Okay, so I'm going to plug in for y here. Again, y equals this So this is going to get plugged in there. That's all I'm doing. So I would have what? In equation 2, negative 2x minus 5. I've got to use parentheses here because 5 is multiplied by y, and y is this. Y is the quantity negative x plus 5. And this equals negative 10. So notice that I have substituted in for y in the second equation, and the result here is a linear equation in one variable. I now only have to deal with x, and that's pretty easy to do. So I have negative 2x. I have negative 5 times negative x, that's plus 5x. And then negative 5 times 5 is minus 25. And this equals negative 10. Combine like terms on the left. Negative 2x plus 5x is 3x. Then minus 25 equals negative 10. Let's go ahead and add 25 to each side of the equation. This will cancel. We'll have 3x is equal to negative 10 plus 25 is 15. Let's scroll down and get a little room going. We divide both sides by 3, and we get x is equal to 5. Now, for the ordered pair that is my solution to the system, I already know that x is 5. So let me erase everything I've done to this point. So we know x is 5. So as an ordered pair, I'd have 5 comma something. Now, how am I going to get this other something? Well, 5 works as a solution for x in both equations if it's a solution for the system. So I can plug a 5 in for x here in equation 1 or here in equation 2 and solve for the unknown y. So let's go ahead and do it in equation 1 because it's a much simpler equation. So we would have 5 plus y equals 5. Well, we know y equals 0, right? But we can go through the steps. Subtract 5 away from each side of the equation. This will cancel. You'll get y is equal to 5 minus 5 is 0. So 5 comma 0. Now, again, I want to check this to make sure that my answer is correct. So let's erase everything. We have x plus y equals 5. So x is 5 plus y is 0 equals 5. We know that's true. 5 equals 5. We just did that. So the other one, you would have negative 2. So negative 2 times, plug in a 5 for x, minus 5 times, plug in a 0 for y, equals negative 10. Negative 2 times 5 is negative 10. Of course, negative 5 times 0 is 0. So I get negative 10 equals negative 10. So that's true as well. So we verified that the ordered pair 5 comma 0 is the solution for this system. What if I would have, let me just throw this out here. What if I would have chosen equation 2 to start out with, and let's say instead of solving for y, I solved for x? Would I get the same answer? The answer to that is yes. Let's go ahead and do that. So I have negative 2x minus 5y equals negative 10. So I'm going to solve for x. So I'm going to add 5y to both sides of the equation. So this will cancel. I'll have negative 2x is equal to, you'll have 5y minus 10. And then let's go ahead and divide both sides of the equation by negative 2. So this is going to cancel. I'll have x is equal to 5 over negative 2. Might as well just put negative 5 halves times y. Negative 10 over negative 2 is plus 5. So this came from equation 2. So I want to plug into equation 1. And what do I want to plug in for? I know that x equals this value here. Negative 5 halves y plus 5. So x is the same as that. So I'm going to plug in for x in this equation now, and I'm going to plug this in. So when I do that, what happens? I have negative 5 halves y plus 5, then plus y equals 5. So now I have a linear equation in one variable. I just have a variable y, and again, that's very easy to solve for. So if I subtract 5 away from each side of the equation, this will cancel and this will cancel. You'll have negative 5 halves y plus y equals 0. Now, before I do anything else, you know that the answer for y was 0, and you can see that the answer for y would be 0 here. No matter what, when I combine like terms, I'm going to have something times y equals 0. That can only be true if y is 0. Okay? So you don't need to go any further. You've proved it to yourself. But for the sake of completeness, I'm going to go all the way here. So let me bring this up. And let's go ahead and just multiply both sides of the equation by 2. That'll be the easiest way to do this. So 2 times negative 5 halves is negative 5, and times y. 2 times y is plus 2y, and this equals 0 times 2, which is 0. So negative 5y plus 2y is negative 3y, and this equals 0. And of course, to get y by itself, I divide both sides by negative 3. This cancels, you get y is equal to 0. All right, so let's erase everything. And of course, we know that y equals 0. So what is x? Again, plug in for y in either original equation. I can plug into this one or this one, doesn't matter. Let's go ahead and use the second one. So negative 2x minus 5 times 0 equals negative 10. So this will go away. I'll just have negative 2x is equal to negative 10. Divide both sides by negative 2. So this will cancel. Negative 10 over negative 2 is 5, so you'll have x is equal to 5. So I get 5, 0 as the ordered pair, as we already found. So any way you do it, you can solve for any variable in any equation to start, and you're going to plug in for that variable in the other equation. All right, for the next one, we have negative 3x plus y equals 9, and we have negative 7x minus 8y equals negative 10. So the first thing I want you to notice here is that you have a coefficient of 1 on your variable y in what I would like to say is the first equation. So I'm going to label this as equation 1, and this is equation 2, just for reference sake. I say, hey, equation 1, I'm talking about this one. Equation 2, I'm talking about this one. So the easiest thing to do here, since I have a coefficient of 1 there, is to solve equation 1 for y. So let's go ahead and do that. Let's say that we have negative 3x plus y equals 9. All I've got to do is add 3x to both sides of the equation, and this will cancel. I'll have y is equal to 3x plus 9. So that's super simple. All right, now that I know what y is equal to, or what y is the same as, I can plug in for y in the other equation. So I'm going to plug this, again, what y is equal to, or what y is the same as, in for this. So I would have negative 7x minus 8 times, again, it's this whole quantity that y is equal to. So 8 is multiplied by that quantity, so I'm going to use parentheses. 8 times the quantity 3x plus 9, and this equals negative 10. So let's go ahead and solve this equation for x. You'll have negative 7x, and then you'll have negative 8 times 3x, that's negative 24x. Negative 8 times 9 is minus 72. And this equals negative 10. So negative 7x minus 24x is negative 31x. So you'll have negative 31x minus 72 equals negative 10. So let's go ahead and add 72 to each side of the equation. That'll cancel. You'll have negative 31x is equal to negative 10 plus 72 is 62. So as a last step to get x by itself, let's divide both sides by negative 31. This will cancel, and we'll see that x is equal to negative 2. So let's go ahead and erase everything. So we already know that x is equal to negative 2, whereas an ordered pair would be negative 2, comma, and then something. So I can plug a negative 2 in for x in either original equation. Doesn't matter because in terms of the system, I know x is equal to negative 2. So this one's easier to do in equation 1. Let's just use that. So you would have negative 3 times negative 2 plus y is equal to 9. So negative 3 times negative 2 is 6. So you'd have 6 plus y equals 9. Subtract 6 away from each side of the equation, and this will cancel. We'll have y is equal to 9 minus 6 is 3. So my ordered pair is negative 2, comma, 3. Let's erase all this. And so now we just want to check. We want to check an x value of negative 2 and a y value of 3 in each original equation. So I'm going to start with equation 1. I'd have negative 3 times x is negative 2, plus, for y, I have 3, and this should equal 9. We know this works because we just did it. Negative 3 times negative 2 is 6. 6 plus 3 is 9. So you get 9 equals 9. So this works out there. All right, for equation 2, we have negative 7 times x. Again, x is negative 2. Then minus 8 times y, which is 3. and this should equal negative 10. Negative 7 times negative 2 is 14. Negative 8 times 3 is negative 24. And again, this should equal negative 10, and it does, right? 14 minus 24 is negative 10. So you get negative 10 equals negative 10. So you can check this one off as well. So the ordered pair negative 2 comma 3, or an x value of negative 2, a y value of 3, is the verified solution for this system. All right, let's take a look at another one. So we have 6x plus 3y equals negative 12. We have negative x plus 3y equals 23. So again, if I find a variable in my system that has a coefficient of 1 or negative 1, I want to use that as what I solve for. So here, again, with negative 1 being there, I'm going to start out by looking at that. So again, I'm going to label this as equation 1. This is equation 2. So with equation 2, I'm going to solve it for x. So I have negative x plus 3y equals 23. And a couple of things I can do here. I can swap sides with this one and this one. Or I can just move 3y over and multiply both sides by negative 1. Whatever you want to do. Doesn't matter. So let me just subtract 3y away from each side of the equation. That's how I'd like to do it. I'll have negative x is equal to negative 3y plus 23. And let me just multiply both sides by negative 1. So negative 1 times negative x is, of course, x. And this equals negative 1 times negative 3y is 3y. Negative 1 times 23 is minus 23. So I've solved this guy for x. So let me erase this. I'm going to drag this up. And if I've solved this for x, I can plug in for x in equation 1. So I would have 6 times the quantity, 3y minus 23. Again, x is equal to, or x is the same as, 3y minus 23. So I can plug in for x there. So once I've done that, then plus 3y equals negative 12. I have a linear equation in one variable now, and it's easy to solve for that variable. So 6 times 3y is 18y. And then 6 times negative 23 is negative 138. And then plus 3y equals negative 12. So 18y plus 3y is 21y. So I'll have 21y minus 138 is equal to negative 12. Let's scroll down just a little bit. So now if I add 138 to each side of the equation, this will cancel. And I'll have 21y is equal to negative 12 plus 138 is going to be 126. So as a final step to get y by itself, let's divide both sides of the equation by 21. And we'll have that y is equal to 6. Right? 126 divided by 21 is 6. So y equals 6. All right, so let's erase everything. So we know that y equals 6. So the ordered pair would be something, comma, 6. So now I can plug in for y in either original equation. Let's go ahead and use equation 2 because it looks a little easier. So I would have negative x plus 3 times, plug a 6 in for y, equals 23. So negative x plus 3 times 6 is 18 equals 23. I can subtract 18 away from each side of the equation. This will cancel. I'll have negative x is equal to 23 minus 18 is 5. So essentially all I need to do is divide both sides by negative 1 or multiply both sides by negative 1. Whatever you want to do. You'll get x is equal to 5 times negative 1 is negative 5. So my x value is negative 5 while my y value is 6. So the ordered pair negative 5 comma 6. So now what I want to do, I want to go into equation 1 and equation 2, plug in my ordered pair, and see if I've got the correct solution for the system. So I've got 6 times, for x I'm plugging in a negative 5, plus 3 times, for y I'm plugging in a 6, and this should give me negative 12. 6 times negative 5 is negative 30, plus 3 times 6 is 18. This should give me negative 12, and it does, right? You get negative 30 plus 18 is negative 12, and that equals negative 12. So this one checks out. Now for the next one, we have negative, and then I'm plugging in a negative 5. So it's basically the opposite of plug in a negative 5, plus 3 times y is 6, and this should equal 23. The opposite of negative 5 is 5, plus 3 times 6 is 18, and this should equal 23, and of course it does. 5 plus 18 is 23, so 23 equals 23, so we verified this one as well. So our ordered pair here, -5, 6, is the verified solution for this system. All right, so let's take a look at another one. So we have 6x minus 21y equals 2. We have -2x plus 7y equals 1. So again, I'm going to label my equations. This is equation 1. This is equation 2. None of the variables have a coefficient of 1. None of the variables have a coefficient of -1. So pick whatever you want, whatever you think is easiest for you. I'm going to go ahead and solve equation 1 for x because it's the first thing that I see. So if I have 6x minus 21y equals 2, if I'm solving for x, add 21y to each side of the equation. So this is going to cancel. I'll have 6x is equal to 21y plus 2. So now I'm going to divide both sides of the equation by 6. This will cancel. I'll have x is equal to, for 21 and 6, they have a common factor of 3. If I divide 21 by 3, I get 7. If I divide 6 by 3, I get 2. So this is 7 halves times y plus 2 over 6 is 1/3. So x is equal to 7 halves y plus 1/3. Okay, so let's erase this. And so we got this from equation 1. Okay, we got this from equation 1. So I'm going to plug in for x in equation 2. And I'm going to plug this in, right? X equals this, so that's going in there. So what are we going to get? We're going to have -2 times the quantity, 7 halves y plus 1/3, then plus 7y equals 1. So -2 times 7 halves, you can think about -2 times 7 halves like that. This would cancel with this, and you'd have a -7. So this would end up being -7y. And then -2 times 1/3 would be -2/3. And then plus 7y equals 1. Now, what happens here? -7y plus 7y is what? That's 0. This cancels. So what am I left with? -2/3 equals 1. Well, that's not true. That's clearly false. So what happened here? Well, this happens to be a system that has no solution. These are parallel lines. So if your variable drops out when you're doing this, and you end up with a statement that doesn't make sense, like -2/3 equals 1, you have no solution. You have no solution. If the variable were to drop out and you have a true statement, then you have an infinite number of solutions. Now, the easiest way to show this is, again, to solve each equation for y. If they're each in slope-intercept form, you can see that they have the same slope, but different y-intercepts, and so they're parallel lines. So let's put this over here, out of the way. If I solve this for y, 6x minus 21y equals 2. If I subtract 6x away from both sides of the equation, this will cancel. I'll have -21y is equal to -6x plus 2. I then want to divide both sides of the equation by -21. And so this is going to cancel. I'll have y is equal to, so for -6 over -21, negative over negative is positive. 6 over 21, they're each divisible by 3. 6 divided by 3 is 2. 21 divided by 3 is 7. Then times x. And then 2 over -21, we just write -2 over 21. So that's this guy right here. Y equals 2/7 x minus 2 over 21. Okay, let's erase this. And let's now solve this guy for y. So -2x plus 7y equals 1. We'll add 2x to each side of the equation. So this is going to cancel. We'll have 7y is equal to 2x plus 1. Divide both sides of the equation by 7. So this cancels. You'll have, and I'll write this up here, y is equal to 2/7 x plus 1/7. So let me erase this. And I want you to look at this real quick. We know that we have parallel lines when what occurs? We have the same slope, but different y-intercepts. So in this case, the slope is 2/7 for each equation. And the y-intercepts are different. In equation 1, the y-intercept occurs at 0, negative 2 over 21. In equation 2, the y-intercept occurs at 0, 1/7. So, same slope, different y-intercepts, parallel lines, never going to intersect, so there's no solution. Okay, these are parallel lines. All right, let's take a look at another one. So we have negative 2x minus 2y equals 6, and we have 4x plus 6y equals negative 2. So it looks pretty easy if I solve this guy right here for either x or y. That looks easiest to me. So let's label this as equation 1, and this is equation 2. And I'll go ahead and solve equation 1 for, let's say, x. So negative 2x minus 2y equals 6. Let's go ahead and add 2y to both sides of the equation. So that'll cancel. We'll have negative 2x is equal to 2y plus 6. And as a final step, let's divide both sides of the equation by negative 2. So that'll cancel. I'll have x is equal to 2 over negative 2 is negative 1, so negative y. 6 over negative 2 is negative 3, so minus 3. So x is equal to negative y minus 3. So now what am I going to do? I'm going to plug in for x in equation 2 now. I found out that x is equal to, or x is the same as, negative y minus 3, that quantity. So I can plug in for x in the second equation. So 4 times, again, this quantity here, negative y minus 3, then plus 6y is equal to negative 2. All right, so 4 times negative y is negative 4y. 4 times negative 3 is minus 12. Then plus 6y equals negative 2. All right, so negative 4y plus 6y is 2y. Then minus 12 equals negative 2. And again, if I add 12 to both sides of the equation, that will cancel. We'll have 2y is equal to negative 2 plus 12 is 10. As a final step, I'm going to divide both sides by 2. And we're going to get that. Let me kind of scroll down a little bit. We're running out of room. So this will cancel. Y is equal to 5. Let's erase everything. So we say that y equals 5. So as an ordered pair, something, comma, 5. All right, so I'm going to plug in for y in either original equation. Equation 1 or 2 doesn't matter. Let's go ahead and pick equation 2. So I'm going to plug in a 5 there. So I would have 4x plus 6 times 5 is 30. So plus 30 equals negative 2. So let's subtract 30 away from each side of the equation. This would cancel. 4x is equal to negative 2 minus 30 is negative 32. As a final step, let's divide both sides by 4. And this is going to cancel. We're going to end up with x is equal to negative 32 over 4 is negative 8. So my x value is negative 8. My y value is 5. Or again, the ordered pair, negative 8, comma 5. So let's check this. I'm going to go ahead and plug into each original equation. So in equation 1, I have negative 2 times negative 8. That's my value for x. Minus 2 times 5. That's my value for y. And this should equal 6. Negative 2 times negative 8 is 16. Negative 2 times 5 is negative 10. And then we have equals 6. So 16 minus 10 is 6. So you get 6 equals 6. So it works out here. In the second equation, remember that's what we use to find x. We know it already works, but let's substitute it anyway. So 4 times, we have negative 8 for x, plus 6 times, we have 5 for y. This should equal negative 2. 4 times negative 8 is negative 32, plus 6 times 5 is 30. This should equal negative 2, and of course it does. Negative 32 plus 30 is negative 2, so negative 2 equals negative 2. So it works out here as well. So we verified that the ordered pair, negative 8, comma 5, is our solution for this system. All right, let's take a look at one more problem. So we have negative 4x plus 8y equals 16, and we have x minus 2y equals negative 4. So I noticed that this equation here, and I'm going to label this equation 1 and equation 2, this equation 2 has a coefficient on x that is 1. So when that occurs, it's like hitting the lottery, right? You want to solve for that one. I've got to use that because it's easy. So I'm going to say, okay, I have x minus 2y equals negative 4. I'm going to add 2y to both sides of the equation. This will cancel. We'll have x is equal to 2y minus 4. So now, if I know what x equals, or what x is the same as, I can plug in for x in equation 1. So I'm going to plug this quantity, 2y minus 4, in for x there. So I would have what? I would have negative 4 times the quantity, 2y minus 4, plus 8y equals 16. So, and let me kind of do this off to the side here. Negative 4 times 2y is negative 8y. Then negative 4 times negative 4 is plus 16. Then plus 8y equals 16. Negative 8y plus 8y is 0. This cancels. Uh-oh, my variable dropped out again. So I have what? I have 16 equals 16. Or if I subtracted 16 away from each side of the equation, I'd have 0 equals 0. So what I told you when we had that example with no solution, if the variable drops out and you're left with a true statement, like you are here, you have an infinite number of solutions. You basically have the same equation for equation 1 and 2. It's just algebraically manipulated to look different. So let's just write that. We have an infinite number of solutions. How could we prove that these two equations are the same? There's a number of different things we could do. The easiest thing you could do is look at it and say, well, if I multiplied this right here, equation 2 by negative 4, on both sides, I would get equation 1. So negative 4 times, the left side is x minus 2y. The right side is negative 4. So multiply that by negative 4 as well. So negative 4 times x is negative 4x. Negative 4 times negative 2y is plus 8y. This equals negative 4 times negative 4 is 16. So now I took equation 2, I multiplied both sides by the same non-zero value, and I came up with equation 1. Negative 4x plus 8y equals 16. Negative 4x plus 8y equals 16. So it's the same equation. Now the other thing we could do is we could solve each equation for y, and again you'd see that you have the exact same equation. So if I subtract x away from each side of the equation here, I'd have negative 2y is equal to negative x minus 4. Divide both sides by negative 2. So that would give me y is equal to, negative over negative is positive, so 1/2 times x, negative 4 over negative 2 is plus 2. Now for this one, up top, if I have negative 4x plus 8y equals 16, I would add 4x to both sides of the equation. That would cancel. I'd have 8y is equal to 4x plus 16. Divide both sides by 8. And I would get what? 8 over 8 is 1, so you'd have y is equal to 4 over 8 is 1/2 times x plus 16 over 8 is 2. So when we look at the two equations, again, they are the same. We have y equals 1/2 x plus 2, y equals 1/2 x plus 2, same slope, same y-intercept, same equation. So of course, whatever solution works in equation 1 also works in equation 2 because they are the same equation. So there's an infinite number of solutions for this system.